Okay, so assume a village, and let's say like the population is 1. So it's like 100% of people, right?
So it's me.
No. What are you talking about? No. Let's say the total population of that village is 1, right? And
Okay.
each person in the village can either run as a candidate in an election or just vote.
Okay.
There's a line where each candidate stand, like each candidate and villager stand from 0 to 1. So 0 is let's assume like it's the most leftist, and 1 is the most rightist. Is that how you say it?
I don't know. Wait.
Yeah. Yeah, you get what I mean. So yeah, so and the villagers will vote for the candidate that is the closest to their position, political position. Yeah. So for example, if there's a candidate and that line is from 0 to 1. So if there's a candidate at 0.2 and there's a candidate at 0.6, then everyone from 0.6 to 1 is going to vote for candidate 0.6, and everyone at
Yes.
0 to 0.2 is going to vote for candidate 0.2, and everyone from 0.2 to 0.4 are going to vote for candidate 0.2, and everyone from
the closest one.
Yeah. So in that case, candidate 0.6 is going to win, right?
Okay. Yeah, because they got 60% of the vote.
And now, when a candidate wins the election, they get a total happiness of A, right? And the cost of participating in the election, like for the campaign, is B. And assume that A is 2 times B.
Okay.
Right? So if you win the election,
the happiness is twice.
Yeah, so if you win the election, it's worth it to run. But if you lose, you just lose out on the campaign money.
Okay.
Sit up straight. Okay. And
I am straight though.
if you're at a position X on the 0 to 1 political viewpoint scale, you're at the position X, and someone at position Y wins, you lose the amount of difference between X and Y. So the distance between X and Y is the amount that you lose.
Of happiness.
Yeah. Okay.
Okay.
Now in this problem, think of in what situations could this election play out?
Okay. So we have an election. How many candidates do we have? 2?
No, everyone in the village can be candidates. Yeah.
Oh.
So each of the villagers have a choice to either run in the election or not run in the election. They can't change their position in the political scale.
Okay, but they can either run or vote. With votes running and voting, they get or lose happiness, right?
Yeah.
So if you win, if like the candidate you want wins, how much happiness do you get?
You don't get any happiness. Like, if a candidate that is not on the same place as you wins, you lose out on the difference between where you stand and that candidate stands. So like if you're at 0.3, and if a candidate at 0.7 wins, you get minus 0.4 of happiness.
So voting never brings you happiness.
Yeah.
Not even if the candidate you want wins.
Yeah.
So here the thing is, either voting the right person to not win happiness, or doing an election to win happiness.
Yeah.
And I'm guessing one of the important questions would be, is it more worth it to run and lose, or vote someone that is going to lose and then lose out on those points?
If you run and lose, you're gonna lose out anyway. So like, for example, if you're at position 0.3 and
Yeah.
a candidate at 0.6 runs, the one at 0.6 will win, obviously, right?
Yeah.
And then you're gonna lose, you're gonna have minus B from the campaign costs and minus 0.4. 0.3 from the
Okay.
difference. But if you don't run, you're only gonna
Yes.
have minus 0.3.
This is a very sad exercise. No one gets happy except the one who wins.
Yeah.
Is this like real life? No one actually wins? Anyway. This is a very good question. How many people are in the village?
There's a total of 1 population. So the think of it as a percentage. There's 100% of people in the village.
Okay, so if there's one person, which is me, I'm just gonna vote for myself.
No. You can think of it as 100 people.
No, yeah. I understand. So the total population is 1, and we're measuring people based on percentage.
Yeah.
But then again, it could be again. I'm kidding. And do we know, like... No, we don't know. Like, we don't know how distributed people are in the political spectrum. So if there's like an average of 0, 0, 1, 0, 2, 3, 3, or like a bell curve where most people are near 0.5.
No, they're equally distributed on the line.
Okay. That's cool. That's important information to know. So what are most people gonna do? I'm guessing, like, ideally you would vote for the person with 0.5. Because I guess that's the option that minimizes everything, right? Because what motivates someone to vote versus running? I'm guessing you need to be really, really sure if you're gonna run, because if you don't, you lose more than if you vote.
Yeah.
Then again, running for an election is the only way to win happiness.
Okay, I'll give you a hint. There are 2 cases in which this election plays out, and one is where there is only 1 candidate, and another is where there are 2 candidates.
Right, so I'm guessing if there's like only 1 candidate, it's going to be near the center. Because like if you're on like the sides, if you're like, man, you're like 0.0, you're super leftist, you're building machines for bike stalling, right? If you risk that, like, by doing that, you risk the most unhappiness, right?
No, that's not the point. Okay, so how you're supposed to think? No, you don't think about other people's happiness. So
you're only supposed to think about your own.
Yeah, so if someone at point 0 decides to run, they will soon realize that they don't have a chance and decide not to run.
Yeah, that's what I'm thinking. Like 0 sounds like the worst possible choice if there's one candidate. Especially because no one's going to vote for 0.
Why not?
Like it's because if they're equally distributed, any other candidate has more of a chance. Because 0 only has votes to the right, well, any other candidate has voters both to the left and to the right. So both 0 and 1 are the most disadvantageous ones. And I'm guessing that's basically holds true for, not holds true, but kind of is similar to with any number, that the farther away you're from 0.5, the less of a chance you actually have. So therefore, the ideal candidate would be 0.5.
Okay, so
Right.
this is what you need to consider in economics. So you're just guessing right now that if there's a case where only one candidate participates, it's gonna be 0.5.
I mean, I kind of am guessing that based on the fact that any other candidate is at a disadvantage if a candidate at 0.5 decides to run.
Yeah. Yeah.
Because as soon as someone goes in, someone with 0.5 can go in and decide, oh, I'm gonna get more votes than them just because I'm in the middle.
Yeah.
And go in.
Yeah. So how to
So
the mathematical explanation is that when someone that's anywhere else other than 0.5 decides to run, like they're like, oh, I'm gonna run, and they become a candidate, the person at 0.5, so you're gonna see, oh, if I become a candidate, I'm gonna win and I'm going to get more happiness. So they start running, and the other person drops out. And once the person at 0.5 starts running, everyone at anywhere else on the line will not participate because they know that they're not going to win. Okay, so using that logic, try to figure out what's going to happen if there are two candidates.
So if there's two candidates, and you can drop out, you're gonna drop out if you find that the other person is closer to 0.5 than you are, right?
No. What I'm saying is that there's a case where there are two candidates and no one drops out.
Okay. Well, I mean, you could do that. So let's see. We have two candidates, right?
So no one drops out or anyone joins.
Okay. So there's only two candidates. No one can join, no one can. But yeah, in that case, still, the person that's closest to 0.5 ends up winning. Unless they're both equally distant from 0.5. Because at 0.25 and 0.75, you get a tie.
Yeah.
Right? And if not, the person that's closest to 0.5 gets more votes.
Okay,
now, who would join in?
Think about the explanation that I gave you, like the mathematical explanation. You said that if there was one at 0.25 and 0.75, they would both get equal votes and win. But in that case, what if the person at 0.5 joins?
Okay, so they can join. Someone could join in the fray.
So So in that case, in your scenario, if the person at 0.5 joins, the person at 0.5 is going to win.
Are they?
Oh wait, no, they're not.
I don't think they are. No, they're not. They're going to get less votes than the people on the sides because they're going to get 25, and the other ones are going to get 37.5% of the vote. So they would not join.
Yeah, so okay, then that would be one case where there are two candidates because nobody is going to join and nobody's going to drop out.
Yeah. In fact, you could probably even calculate the equilibrium point at which it starts being favorable for 0.5 to join in.
Yeah, that's the whole problem. I mean, that's the whole question.
Right? Because there's a point, basically, which I'm guessing it's 1/6 and 5/6, where if 0.5 joins in, they both get 33. All people get 33.3% of votes. If the candidates are spread further apart, then it's favorable for 0.5 to join in. If they're closer together, 0.5 can't join in. I mean, they can, but they're going to lose.
Yeah, so if they're further apart, when 0.5 joins in, the two candidates are going to drop out, and it goes back to the one candidate situation.
To the one, yes.
Yeah. So what's the answer for the two candidate situation?
Yeah, but like I said, it depends because if they're very spread apart, right?
No, so okay, so when I ask for an answer, you need to say it like this: two candidates will run in the election if candidate 1 is more than 1/6 and candidate 2 is less than 5/6.
5/6? Yeah. Yeah. So, if candidate A is if their political score is less than 0.1666 or 1/6, and candidate B's score is more than 5/6, so 8.333, candidate C that's at 0.5 will join in and win. The other two will drop out.
Yeah, so that's not
However,
that's not going to be a two candidate situation. That's just situation 1, where one candidate is.
Yeah.
So the answer is that.
So that's not.
There's one situation where one candidate is at 0.5, and there is a second situation where there are two candidates and one is at more than 1/6 and the other is at less than 1/5. No, 5/6.
5/6. Yeah. In that case, there's an equilibrium where no other candidates will go in. Because if they do go in, either they're 0.5, which means they lose, and the other two candidates still win. Right? Like, it would make no sense for them to go in. Or if they're at any other point that's not 0.5, they shift the scale so that if they go on the side that's less than 0.5, the candidate that's at more than 0.5 would win. And if they go to the right of 0.5, then the candidate who's at the left of 0.5 would win. So it would also make no sense for them because they would lose themselves.
Yeah, so they will not join.
So they will not join. So if the two candidates are equally spread apart, right, and they're more than 1/6 and less than 5/6 respectively, then that's a stable two candidate situation.